What's up, 7th grade? Mr. Agnos here. This video is for homework 2-2. And remember, this topic, or this unit, is all about proportional relationships. And last time I mentioned that you guys already know what a proportional relationship is, right? If we're looking, and I use the example of inches to feet, or I should say feet to inches. So if I made a little table, and last week we looked at tables, right? So if I said, okay, if I have this many, if I have feet over here, and I have inches over here, and I made a table, what would it look like? Well, if I have 0 feet, I have 0 inches. 1 foot, I have 12 inches. And 2 feet, I have 24 inches. 3 feet, I have 36 inches, and so on, right? And this is something that you guys know. And we just kind of added some new terminology to this, right? Well, if you look at this table, if you take whatever's on the left-hand side and you multiply it by 12, you get whatever's on the right-hand side, and that includes the 0, right? 0 times 12 is 0. 1 times 12 is 12. 2 times 12 is 24. 3 times 12 is 36. In other words, I could give you any number of feet, and you would just multiply that by 12 and tell me the number of inches. So we call 12 the constant of proportionality. Proportionality. There we go. And the way that you can find it, I mean, sometimes you can just look and it's kind of obvious, but the way that you find the constant of proportionality, so I'm gonna call it the C of P, is this ratio of y to x, right? Y over x. Now you might be saying, hey, Mr. Agnos, where's the y and the x? Well, when you have a table that's arranged vertically like this, the left-hand side is always our x's, the right-hand side is always our y's. And so you can see that if I made a ratio of y to x here, I would have 12 over 1. Well, that's equal to 12. That's this point right here. This does not work for 0 over 0, so you never use that point. If I did 24 over 2, that is equal to 12. And if I did 36 over 3, that is also equal to 12. Excuse me. Okay. And then the last thing is, remember, if we have a table that is arranged horizontally, like so, then our x's are always on top and our y's are always on the bottom. So in this case, what would that look like? Well, I'd have 0, 0. I'd have 1 foot, 12 inches here. I'd have 2 feet, 24 inches here, 3, 36, 4, 48, and so on. Okay? But all of this still applies. Okay, a table is one way to give you information. This week, we're going to be looking at a graph. And because I can take this same information and graph it, right? If I think of each of these as coordinate pairs, right? In other words, if I think of 0, 0 here as the point 0, 0, also known as the origin, and if I think of this as the point 1, 12 and 2, 24, and I keep going here, well, I could put all these points on a graph, right? And what would that graph look like? Well, that's what we're talking about this week. And it turns out that proportional relationships all have graphs that look very similar. So at several points during this video, I'm going to tell you to pause the video and write this down, right? Okay, every proportional relationship, or I should say the graph, right? We're talking about graphs this week, so I'm not underlining this. The graph of every, right, underline that, proportional relationship has 2 things in common. I'm just going to write the graph of every proportional relationship we have 2 things in common, okay? Number 1, straight line. It will always be a straight line. Now, that means something different in math class and maybe in art class, right? A line in math has to be perfectly straight. So in art class, you might say, oh, that's a beautiful curvy line. That is not a line in math. In math, a line is perfectly straight. Okay, maybe it goes this direction, maybe it goes that direction, maybe it goes this direction, but they are perfectly straight. If it is not a straight line, it is not proportional. And the second thing, for it to be a proportional relationship, it has to pass through the origin. Has to pass through the origin. And remember, the origin is the point 0, 0. Okay? And when we looked at our table earlier for feet in inches, right? And I had feet over here, and I had inches over here. If I have 0 feet, I have 0 inches, right? Well, this idea of 0, 0, it holds true for everything that's proportional. If I have 0 dozen donuts, then I have 0 donuts. If I score 0 touchdowns, then I have 0 points, right, from touchdowns. So these two things have to be true. So go ahead, pause the video right now, write these two things down. Okay, so now let's look at the first question. They say, which of the following graphs show proportional relationships? Choose the correct graph below. Well, let's look at graph A. That is not a straight line. That is a curved line. So it fails number 1 in our checklist. This is not a proportional relationship. Let's look at choice B. This is a straight line. Perfect. Then proceed to number 2. Does it pass through the origin? The origin is this point right here. And as we can see, our line does not pass through that point. If we extend our line would actually go off like this. It does not go through the origin, right? This would be like if you had 0 dozen, if you look at this, it's saying, like this is a 1 here, I think. Well, I scored 0 touchdowns, but I still have 1 point from touchdowns. But I didn't score any touchdowns. Or I have 0 dozen, but I still have 1 donut. Like, it doesn't make any sense in terms of proportional relationships, right? So this one is not a proportional relationship. Contrast those two with this guy over here. It is a perfectly straight line, so that checks off our first box, and it passes through the origin. That checks off our second requirement. So this is the only graph of a proportional relationship. So choice C, final check, got it. I'm gonna do another example. Similar question, right? Look at these 3, right? And again, you get really good at this. No, it's curved. Boom. Yes, straight line goes through the origin. There it is. It's a straight line, doesn't go through the origin. All right, so for this one, you check B. Final check, got it. Boom, similar question again. Look at choice A. Does a straight line goes through the origin? Yes, that one's good to go. This is not a straight line. It's bent. Nope. And this one is a straight line, but it doesn't go through the origin. No. Got it. Okay, so that's the first thing that you're going to be asked to do is identify proportional relationships by a graph. Is it proportional or not? Well, they're also going to ask you to identify a proportional relationship from an equation. Okay. So what do I mean equation? Well, again, think about touchdowns to points. And remember, on the left-hand side here is my x's, right? If we're thinking mathematically. And on the right-hand side is my y's. And I can fill this out. Again, 0 TDs, 0 points. 1 touchdown, 6 points. 2 touchdowns, 12 points. 3 touchdowns, 18. And so on. So I can actually write an equation here, right? I can say that the number of points, y, remember y is my points, is equal to, well, what's the constant of proportionality here? It's 6, right? I'm always multiplying by 6. So I could write an equation. Y is equal to the number of points, 6, times the number of touchdowns. Whatever x is, multiply it by 6, and that's going to give me my y value. All right? So The question here is, does the equation y equals 11x show a proportional relationship between x and y? And they're having you think about it in terms of a graph. Well, the answer is absolutely. So if I were to make a table, for y is equal to 11x. So here's my x, here's my y. Okay, so I have 0, 1, 2, 3, and so on. So what this equation says is whatever the x value is, multiply it by 11 to get the corresponding y value, right? So what is 11 times 0, right? If I plug in a 0 here, what is 11 times 0? Well, that would be 0. What is 1? Again, I'm just taking whatever number I have here and putting it here. What is 1 times 11? 11. What is a 2 times 11? 22, right? And 3 times 11 would be 33, and so on. Well, if I were to graph these, I would get a beautiful straight line that looks something like this, right? It passes through the origin, and every time I move to the right 1 unit, we go up 11 units. So I go to the right one, I go up 11. I know this is not the scale. I move to the right one, I go up 11. All right? So this absolutely makes a graph that is a straight line and does pass through the origin. And the easiest way to think about this is any equation that is written in this form, where you have y is equal to, and I'm going to use the letter m here for our constant of proportionality. Any equation that is written like this, y is equal to mx, where m is the constant of proportionality, the c of p, is going to be a proportional relationship. So as soon as you see an equation written like this, you know that you're just taking your x value, you're multiplying it by some constant, and it's going to give you your y value. So here I would go, yes, the graph of the equation is a straight line that passes through the origin. Got it. Let's contrast that with number 4. Okay, notice that number 4, the equation is a little more complicated. It says y is equal to 2x plus 5. All right, first thing you need to notice is this equation has extra, right? It's got this extra plus 5. So it does not look like this, right? It does not look like x times some number is equal to y. And if I were to make a table of values here, if I were to say x, y, and I said 0, 1, 2, 3, and so on, well, when x is 0, if I plug a 0 in here, I get 2 times 0 is 0, so this becomes 0, and 0 plus 5 is 5. This is not the origin. Remember, our graph has to go through the origin. This first point here has to be 0, 0, and it's not. So anytime you have plus or minus something, right, plus or minus something over here, it is not proportional. So look at my choices. No, the graph of the equation does not pass through the origin. The last one right here. No, the graph of the equation does not pass through the origin. So I'm going to click on that one. Check answer. Got it. All right, I'm gonna skip all the way to the end here. I'm running out of time, so I know I'm gonna have to do a lot of review here in class, which is fine. Number 14 says, the graph shows the proportional relationship between gallons of blue paint and gallons of yellow paint needed to make a certain shade of green paint. How do you know the relationship is proportional? Well, what are our two things? Passes through the origin and a straight line. So here it says, select all that apply. The graph passes through the origin, 0, 0. The graph is a straight line. There it is, right? None of these other two really matter. Check answer. Got it. The unit rate. I'm almost out of time. All right, the unit rate per gallon of blue paint. Unit means 1. So I go over to 1, I go up, I go over. That would be a 3. I'm out of time, guys. I will